Hey guys, welcome to Unshackling Sudokus and Puzzles. I am Kishore and today I am going to solve a hybrid Sudoku variant created by grkles. This Sudoku was posted on the Discord server of CTC. The link to solve this is given in the description of the video. You guys can give it a shot and then please come back and watch the video. It seems to be a really interesting variant. And let us jump into the rules of the Sudoku now. Classic rules apply. Each row, each column and each 3 by 3 box in the grid will have digits from 1 to 9. And then we come to the variant part. Clues outside the grid give the sum of the digits in that row or column which are on lines. Okay, simple enough. So if you take, for example, this outside clue 10, you just look at the corresponding row, which is row 2, and then sum of the digits which are on the lines in the corresponding row. So which basically means that these 4 digits add up to 10. So the same applies for column. So for example, if you look at column 2, we have a 15 clue outside. So which means that sum of these 4 digits must be equal to 15. So these are the rules. Let us give this Sudoku a try now. So we'll start with this 10 clue as we just saw. 10 from 4 digits is always going to be 1, 2, 3, 4. There is no other possibility. And let us look at smaller clues. Look at this 11 clue, guys. Again, we have 4 cells on lines along row 5, which means that there is only one possibility for the 11. 11 from 4 digits has again only one possibility, which is 1 plus 2 plus 3 plus 5. Right. So now we can look at either 27, or we can just look at the columns which have some filled in candidates already, because they are going to either minimize our total or maximize the other digits on the lines. So maybe let's look at 27. So we have 4 digits on the lines along that row, and we know that 27 from 4 digits always needs to contain a 9, without which you cannot have a 27. So one of these 4 cells must be a 9, and if you don't have an 8, then the sum gets fixed. It should be 5, 6, 7 and 9, but the thing is that 8 can be in one of these 4 cells. Okay, this 17 is interesting, guys. It's really restricted. If you look at these look at this row, there are 5 cells on the lines, and 17 from 5 digits has only 2 possibilities, either 1 plus 2 plus 3 plus 4 plus 7, or 1 plus 2 plus 3 plus 5 plus 6. In both the cases, we know that 1, 2 and 3 must be part of the sum, without which the 17 total will be exceeded. And now this is really helping us, guys. Remember that 20 from 3 digits, right, can never have 1 or 2 as part of the sum. So which means you can straight away eliminate 1 and 2. So this is either 3 or 4. And we can now eliminate all these 1, 2, 3 which we have marked as corner pencil marks. Remember that these are not the exhaustive list of candidates here. We have just corner pencil marked them. However, we can be certain that because of the 20 clue, you cannot have 1, 2 or 3 here. Right? We can remove all, because 3 plus 4 will give you at max 7, and we need 13 more, which is not possible. So I have removed the 1, 2, 3, and now we can write the other possibilities. So we saw earlier that 17 is 1, 2, 3, 4, 7 or 1, 2, 3, 5, 6. So which means that this is either 4, 7, 5 or 6. So these are the exhaustive list of candidates that can go into this cell. Seems to be a really fun variant, guys. So this author Sudoku we haven't covered previously on the channel. So I thought it would be a nice idea to cover a Sudoku by this author, and it seems to be a really good decision. Okay, so I can eliminate 4, 5, 6, guys. So it's really easy to see. If you look at 20 and try to maximize the sum, the only possible maximum sum is going to be 11 from these 2 cells, and that would have to force a 9 here. So which means that these 2 cells must take a maximum value, right? Because if you have 4, 5, 6, then you can maximum get 10 only from these 2 cells, and that's not going to help us. So this must be a 7. and this must be a 4, and now 4 plus 7 is 11, that gives a 9 here. And now we have deduced the possibility for the 17. It must be 1, 2, 3, 4 and 7. So I'll just write 4 in all these cells and make them center pencil marks. So they must be 1, 2, 3, 4, right? And we have deduced this 17 clue. So is it possible to highlight these clues? I don't think this interface allows that. Okay. And now we can reduce these pencil marks, right? This and this becomes 1, 2, 3. 24. We haven't yet looked at the 24 yet. So if I try to maximize the sum, 3 plus 4, 7, and I need 17 more. This is really nice, guys. Superb. Look at this 24. So the maximum total that you can get from these two cells is 3 plus 4, which is 7. And when you take the maximum value, you are just able to reach the total, right? 3 plus 4 gives you 7, and we need 17 more from these two cells. And there is only one way to get 17 from those two cells, which is 8 plus 9. So which means all these cells have to take their maximum values. So this is 3, this becomes 4, this has to be 8, 9, and this has to be 8, 9, but you have a 9 here. So that immediately resolves this column. So that's 8 and that is a 9. So we have got the 24 resolved now, and just I'll remove these. They become 1, 2, 3. Whoa, this is a really mind-boggling deduction, guys. Really nice. So look at this 23 clue. So we have 5 cells along that column, and if you notice closely, so these 3 cells are almost forming a triplet. Without this 5, we could get a triplet. Now for a moment, let's see what happens if this is not a 5. So we get a triplet, and that gives us 6, and we need 23 minus 6, which is 17 from these two cells, right? But 17 from two cells can only be 8, 9, 8, 9. But both 8 and 9 are eliminated from here. That's awesome, right? So which means that we cannot allow this triplet to happen. So this must be a 5. So this would be a 5. This has to be a 5, and these 3 cells can't be 5. So they must be 1, 2, 3, and that gives us a 1, 2, 3 triplet here. That's nice. So I think we can just look at this again. 2 plus 3 is 5, 5 plus 5 is 10, and we need 13 more from 2 cells. I think there is something going on in this column for sure, guys. Oh, that's nice. So the maximum value from this cell is going to be a 6. So if we just put that there, 5 plus 6 is 11, 11 plus 2 plus 3. I'm just taking the maximum values, which is 16. So this must be 7 or 8. Okay, that's nice, guys. So we can do something here. So just try putting the maximum values in all these cells. Let's see how much degrees of freedom we have. So 7, 8, 9. So the maximum value here is 6. And from these two cells, it's going to be 5 maximum. So 2 plus 3 is 5. 5 plus 5 is 10. 10 plus 6 is 16. And which means that we need 7 more. But maximum value we are taking, right? So this must be 8. So we have exactly 1 degree of freedom, right? So we are getting a total of 24 by considering maximum values along these cells. So which means that all these cells have exactly 1 degree of freedom taken together. So we can use that to write the candidates, which means that this must be 7 or 8. No cell along that column which are on the lines can be more than 1 less than its maximum value, as we just saw. This is 7, 8. This has to be 2 or 3, because if you take 1, then it's 2 less than its maximum value, which is not possible. So this is going to be 5 or 6. That is really fine. So we have got something here, but 5 is ruled out, right? The maximum value here is 6, so it can be 1 less than that, but 5 is ruled out, so this must be a 6. So it's really only one possible value that can be here. 11 plus 5, 16 and plus 7. So this can be the only possible value, guys. There is no other thing. Oh, wait. I don't think I'm doing this right, guys. And I think I was wrong in eliminating the 1 from these cells, right? I said that 5 cells taken together have a degree of freedom of 1. But it doesn't mean that this cell cannot be a 1, right? So what happens if this is a 1? 1 plus 3 is 4. Yeah, that's right, guys. You can still see maximum value from these two cells is 5. So even if you have 1 here and a 3 here, you can get a total of 4 and still you're losing only 1 degree of freedom. So what I did was actually wrong. I'm sorry for that. Okay. So I don't think I can have, see, this is not, this cell in particular cannot be 5, cannot be 8, cannot be 9, cannot be 7. Can it be a 4? If it's a 4, 4 plus 5 is 9, 9 plus again 5 from these two cells, which is 14, and you need 9 more. So this can never be a 4 because 9 is not possible there. This has to be a 6. And now we can work out the permutations and combinations. So 5 plus 6 is 11, and which means these three cells must sum up to 12. Okay, if it's 1 plus 2, that gives you 3, and that needs a 9 more here. So this cannot be 1 plus 2. So which means that 3 is definitely in one of those two cells. So it's either 1 plus 3 or 2 plus 3. If it's 1 plus 3, 5, 6 is 11. 11 plus 4 is 15. So this would be 8. And if it is 2 plus 3, 10, 16, 7. Okay, so these are the possibilities here. So this is right. And now, okay, I can reduce these, right? So this is not 3, this is not 3. And we just saw that 3 must be in one of these two cells. So which means that this becomes a 3. And that gives us a 1-2 pair. Really fun Sudoku, guys. So much fun. And we have a pair 1-2 in column 6, right? So this means that this would be a 3. And that must be a 1 and 2. A really nice variant which utilizes the arithmetic portion of the Sudoku excellently. So which clue is getting interesting now? 24 is done. 17 just does not have enough digits to do something in the Sudoku, and 15 may be possible. Let us look at the rows. 10 is done, 27 is almost done. Okay, 27 can help us here. 11 is done, 17 we haven't even begun to write on the 17 clue, and this 17 is also done. Okay, so let us just try something using the classic part. 1, 2, 4, 3 and 7, which means these 4 digits must be 5, 6, 8 and 9, and 8 cannot be in box 9, so these must be 5, 6, 9. This must be 5, 8 because 6 and 9 is ruled out, and this can be 5, 6, 8 or 9. So let us just not focus there. And at this point, I'm not sure how to continue the Sudoku. Okay, let us just try to make use of this clue, guys, because we have two, we have one fixed digit and two candidates written on one of the other cells. So maybe we can use that. So suppose if it is 9 plus 8, that is 17, which means these two cells must sum up to 10. And 1, 9, 2, 8 are ruled out, and 3, 7 is also ruled out, which means this must be 4 and 6. And suppose if I have a 7 here, 7 plus 9 is 16, which means these two cells must sum up to 11, and it cannot be 2, 9, it cannot be 4, 7, and it cannot be 3, 8, so this must be 5, 6. Superb. So common logic is that 6 is definitely in one of those two cells, right? Really interesting at this point, guys. Not sure how to continue here. Okay, and I'm extremely sorry, guys. I forgot to add one important part of the rule. I just saw the rule part again, and I noticed that this exists. Digits cannot repeat along the lines, guys. I'm extremely sorry. I missed that rule part. We can use that. So far we haven't used that part here. So thankfully it didn't really make us stuck at the start. But at this point, I think we need to use that part where digits cannot repeat along the lines. So which means that you have a 4 here. So this cannot be a 4. And 3, 9, 1 and 2, 3, 4. Okay, look at this line, guys. This slanting line has an 8 in row 9 column 8, so which means this cannot be an 8, so that becomes a 7. And now we can resolve this part. 7 plus 9 is 16. We need 11 more from here, so this has to be a 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8. That's really nice. We have a 1, 2 pair along this slant line, which means 1, 2 cannot be repeating anywhere along the line. And I can use that, right? 4, 7, 8, 1 and 2. Remaining digits are 3, 5, 6, 9. And look at this cell. It cannot be 3, 5, 6. So this would be a 9. That's awesome, guys. Superb. Fantastic Sudoku. Fantastic idea, really. So let us focus on this line. We have got 6 digits. So remaining digits are 3, 5, 6 along this line. The portion where the digits do not repeat on the lines is really helping us. So this becomes 3, 5, 6 and that becomes 3, 5, 6 for this line. And what is the thing? Okay, I can use a bit of classic to get the 7 narrowed down there. Can the 7 go along this line? Okay, 7 can go. Okay, let's look at this 17 clue, guys. We got a 9 just now, and now the 17 is becoming really interesting. So we got 9, and which means these 3 cells must sum up to 8, and 8 is not possible with a 6 in there. So this has to be a 5, and this cell must be 1 or 2. That's really awesome. So we got the 17, means 17 clue is done now. And because of this 5, you get a 6 here. So 3, 5, 6, 9. This cell can't be 1 and 2 because of this 1, 2 pair, and this cell cannot be 1 and 2 because of this 1, 2 pair. Right? So both of these cells cannot be 1 and 2, which means they must be 4, 7, 8. So maybe I'll use some coloring here, guys, because lots of 1, 2s are there. I'm just going to color them. It's easy to see, right? So because this is green, this cannot be green, so that would be a red, and that becomes a green now. So where do we start to look at now? Okay, I can use some classic here, gives a 9 here. Row 5, I can get a 9, so 9 goes in one of these 2 cells. I get a pointing pair of 9s. This line is suddenly appearing really interesting. I have 1, 2, 3, 4, 5, 6, 7, 8. 8 cells, out of which 3, 4 and 5 are already on the line. Okay, let's use some classic here. 5 is in these 2 cells. That gives 5 in one of these 2 cells because 5 cannot be on the line. Six is in row 9, 6 is in column 6, and 6 cannot be on the line, so 6 goes in one of these 2 cells. Okay, this is a really sharp deduction, guys, but I'm going to use that. So this cell cannot be a 5. So I know it's pretty random. Out of all of a sudden I look at this cell and say that this cannot be a 5, but basically the idea originated from by looking at these three cells and noticing that there is an outside clue. So if this is 5, then I know that these two cells must add up to okay, what I did was not right, so just forget what I said, guys. This is not going to work. Let's look at row 5. So 1, 2, 3, 5 and 9. Remaining digits are 4, 6, 7, 8. I have 4 and 7 here, so that's a 6, 8. And this cannot be 4, 8, so that's a 6, 7. So this must be 4, 6, 7, 8. Okay. And if I look at row 2, I have 3, 4, 1, 2 pair and 5 and 9. So I have only 3 candidates in this cell. That must be 6, 7, 8. Oh, I haven't looked at this clue, guys. Look at this 17. We got a 9 on that line. So which means these 3 cells must add up to 8. There is only 2 possibilities. 1, 2, 5 or 1, 3, 4. So let us try to write them. 1, 2, 3, 4, 5. So if you write the candidates exhaustively in all these cells, they are basically 1, 2, 3, 4, 5. 5 is not here. 3 and 5 is not here. And this cannot be a 5 because you have a 5 here. So which means that you will see that 5 is eliminated from all these 3 cells. So there is only one possibility to take the 8, which is going to be 1, 3, 4. That's really nice. So those cells become 1, 3, 4. And that eliminates the 4 from here. And because of this 4, you get the 4 removed from here. And that 3 removes the 3 from here. And now just this 15 clues yet to be exploited fully, right? Okay, 23. Oh, I should have done this earlier, right? We have got all the digits here. 3 plus 6 is 9, 9 plus 5 is 14, 14 plus 7, 21, and which means that this would be 2. I don't know how that was, how much time that was there sitting like a duck. Should have seen this earlier. So this becomes 2, that becomes 1. So not easy to look at these kind of things during a live solve. So 2, 1, that gives a 2, that gives a 1, that gives a 2. All the green cells become 2, all the red cells become a 1. And because of this 1, I get a 4 here, and which means this must be 1 and 3. And you have a 3 here, right? So this cannot be repeating. So this becomes a 1, that gives a 3 here, and which means this is not 3. And so 4 is eliminated from here. You have a 4 here, so this means that you have only one cell for the 2. And 2 is in row 1, row 4 and row 5, so that gives me a 2 in this cell. You can't have 2 here. And which means that gives me a 2 pointing pair of 2's here. So now I think we can make use of this 15 clue, and that should be really helpful in continuing the Sudoku. So I have a 3 on the line, so which means these 2 cells must sum up to 12. So which means this cannot be a 6. So that has to be a 5. That gives oh, did I make a mistake? Oh, I'm sorry guys, it has actually 4 cells on column 2, right? I was actually seeing only these 2 cells, some form of blindness. So which means that these 3 cells add up to 12, right? Okay, that is really restrictive, I think, because you already have 5 digits along this line, which means this can only be 6, 7, 8, 9, and 9 is not possible. So 6, 7, 9, 6, 7, 8, and okay, that's good, guys. So you cannot have 7 or 8 here. Look what happens if this is 7. 7 plus 5 is 12, and 12 plus 3 is 15 already, and you have one more cell on the line. So this can only be a 6. That becomes a 7 now, because due to classic you can get the 7 here. That 6 gives me a 5 here, and 5 plus 6 is 11 plus 3 is 14, and you get the 1 here. Superb, right? Really fun Sudoku, guys. It's so much fun to fill your day with such beautiful Sudokus. So I'm really thankful to grkles for creating this Sudoku. Okay, so 2 goes here, right? And 5 gives an 8 here. So 1 3 7 8 2 6 9, and which means that this must be a 5 and that must be a 4. Because of this 5 you get a 5 and 4 here, and so you have 6 7 8 triplet in row 5, and that gives a 4 here. And we can complete column 2 now. Only one cell left for the 4. So 4 5 7 9 2 and 3, which means that I have 1 6 8 left to be filled, and 1 is here and 6 is here. So this must be 8, and that resolves this 7 8 pair. That 8 gives a 6 here and a 7 here, and which means this must be a 1. So I can complete column 1 now. 1 2 6 4 5 7 9. So this must be a 3 8 pair, and this must be a 1 9 pair. So all the digits now are settling very well in place. Okay, look at this. This cannot be 7, this cannot be 8. So this would be a 6. And I can fill in this pair 1 4 7 9 2 3 8. So this must be a 5 6 pair. And that gives a 3 8 pair in row 4. So if I look at row 2, I have 2 4 7 and 1 3 6, which means these three cells must be 5 8 9. And are all the clues done on the lines? Okay, I think yes. Okay, let's look at column 5. Okay, you have a 6 here, so that gives me a 6 here. This is not a 6, which means this would be a 5 9 pair. And 4 5 7 1 2 9 and 8. So this cannot be a 5, because you have 5 already on the line. 1 3 4 5 2 6, which means these two cells must be 7 8 9. Digits don't repeat on the line, so this cannot be a 9. Sorry, this cannot be an 8, and this can be okay 7 8 and 9. You have a 5 9 pair here, right? So this is a 7, and that removes the 7 from here. It's lying on the same line. 2 5 6 8 1 and 9. Okay, so these cells must be 3 4 7, and 4 and 7 get removed from this cell, so that's a 3, which means this is 4 7, that's 4 and 7. That 3 gives me a 6 here. 4 6 7 8 5 and 9. So these 3 cells must be 1 2 3, and 1 and 3 gives me a 2 here, which means these must be a 1 3 pair, and that is immediately resolved. So that's a 3 and that's a 1, and that 3 resolves this 3 8 pair, 8 and 3. So 1 3 8 and 2 6 9. So which means that I can write in the digits 4 5 7. 7 does not go here, and 4 does not go here. So 1 2 3 6 4 5 and 7. So these two cells must be 8 and 9, and I get an 8 9 pair now in column 4. So which means this must be a 5. 8 9 gets eliminated there, so this must be an 8 9, and that 8 gives a 9 here and an 8 here. And because of this 9, I get a 5 and a 9, and I can fill in the column 7 now. 1 2 8 9 3 5 6. So this must be 4 7 3 8 9 4 and 7, and the leftover digits are 1 2 5 and 6, right? So 2 cannot be in column 8. 2 has to go here, and you have a 2 here, so which means it cannot repeat on the line. So I get my 2 in the box. That becomes a 2, and this has to be 5 6 for the column, and these two cells must be 1 5 6. Okay, you have 5 here, so that's a 6, which means this must be 1, and that 6 resolves this 5 6 pair, 6 and 5. That becomes a 5, and that 1 gives me a 9 here, which in turn gives a 1 here, so 9 becomes a 8 here, which means this is 9, this is 8. That 8 gives a 3 here and an 8 here. 5 here gives me a 7, 4, 5, 2, 5, 8, 3, 6, 7 and 1. So these two cells must be 4 and 9. And I can quickly resolve that. So that's a 9, that's a 4, that's a 4, that's a 7. That 4 gives me a 7 here and a 3 here. And with that we have completed this simply stunning construction by grkles, an amazing Sudoku, so much fun deductions. It was not so hard, but at the same time it used the node repeating part really well, and even the arithmetic was really fun to solve. Hope you guys enjoyed this fun Sudoku by grkles. So I really enjoyed solving this Sudoku for you guys, and please let us know your thoughts in comments and do subscribe to the channel now. So hope to see you soon. Bye bye.